Alright everybody, welcome back to the YouTube channel, and today I'm going to be teaching you permutations versus combinations, right? And so, these are really easy topics, but they're really useful. They have a lot of application uses, and then they're kind of like a stats topic. So, permutation is, I'll make an example here. Say I have 3 shapes, right? And I have a shelf that I want to put these shapes on. So permutating would mean that I want to find all the different ways I can put these items on the shelf without repeating with repeating like the number of things on the shelf. So this is where order matters. So this is where I would count this first one and then this second one as two different scenarios, because as you see, the order of the first two were swapped. Now, if we were combinating, I would say that these two, I would say that these are, in the sense of combinating, they're the same outcome. So, now, the formula for combinating and permutating are very similar because they're very similar ways of solving a problem. So combination is where n is the number of things you have in total in your sample group, and then r is the rate at which you take these and then you combinate them, if we're doing combinations, right? So I would say I have 5 shapes, and I can fit 3 of these shapes on a shelf, right? How many different ways are there for me to put the shape on the shelf? And they say that order matters, right? So if order matters, that's obviously a permutation question. And the formula for permutation is n factorial over n minus r factorial, okay? It's a very important formula. Okay, so now that we've got this really important formula, as I said, there's 5 shapes, and they want to take them, you can fit 3 shapes on the shelf at a time. And order matters, okay? That means permutate. And this is the permutation formula. As you'll see, there's n factorial over n minus r factorial, the total sample size factorial divided by total sample size minus the rate at which you're permutating, factorial. So in this case, it would be total sample size is 5 over 5 minus 3 factorial. Or I'm sorry, it's 5 factorial. And, well, you could, kind of just work it out because these are somewhat small numbers, but it's really annoying. So if you go to your calculator and then you go to the probability section, you'll see a little function called NPR. NPR means permutating. So in the n slot, you would put 5 because that's the amount. And in the rate, you would put 3. And that would give you 60. So there's 60 different ways to put 3 things on a 5 shapes, 3 things on a shelf at a time. There's 60 ways you could put them on there. And remember that order matters, okay? But say order didn't matter, right? Order didn't matter, and this is counted essentially as the same thing as that, where order doesn't matter. You can just kind of have it in any order you want, and it wouldn't count as a different outcome. So that's when you use combination. And you'll see that with combinations, since there are less outcomes, right? Because you wouldn't count things twice in combinations. So you have less outcomes, which means you basically just have the, what's it called? The permutation formula, but you add an extra part where you divide it also by the rate which you're dividing. So that makes sense because this is obviously a smaller number, and with combinations, you will obviously have a less amount of outcomes as permutations, right? So in this case, you would have your n is oh goodness, I'm sorry. Your n is 5 factorial over 3 factorial times 5 minus 3 factorial. And let's put that in a calculator. That'll give me 5, 3. That'll give me 10 outcomes. So that's a lot smaller than permutating. Instead of permutating, I'm going to write NPR, okay? Instead of permutating, if I combinate, I will get a lot less outcomes, alright? So, in a nutshell, that's kind of how you do permutations and combinations. Remember, permutation formula is always going to be n factorial over n minus r factorial that equals NPR. That's what this is what the function will look like in the calculator. All right, NPR, and n is your total sample size, and then r is rate. And then obviously your combination formula will give you less outcomes because you don't count things twice, right? So you would do n factorial over r factorial times n minus r factorial. And this will obviously give you a smaller number than just this up here because you have the r, okay? Very important stuff. And that's just like basics on how to do it. And remember, order matters with permutation, but order does not matter for combination. So I hope this was helpful for you, and good luck on your tests.